Welcome, I'm Mr. Rankin. Let's get to our Chapter 5 examples. We've got 41 of them, so we'll see how many we'll get through in each video. But let's start off with the classical definition of what probability is. So probability is just the likelihood of an outcome, normally measured from 0 to 1 or sometimes put in percentages from 0 to 100%. So the classical definition of probability that you've probably seen is the total number of successful outcomes divided by the total number of possible outcomes. So for example, to make it clear, if we're rolling a dice, one dice, probability of getting a 5, one way we can be successful, 6 possible ways, probability of rolling a 5 is 1/6. We said, what's the probability of rolling a 5 or a 6? Now we would have 2 successful. We're successful if we roll a 5 or a 6. So now we would have 2 successful outcomes divided by 6 possibles. So same thing, 4, 5, and 6. It would be 1/2, right? 3/6. We could do the same thing with consumers, as in the book, whether they like a product or dislike a product. 4 people, what's the probability at least one will like it? Well, one could like both. That would be a successful outcome. One could like the first product, not the second, but that would still be a successful outcome. One could like the second product and dislike the first. That would be a successful. So we've got 3 ways of being successful. And there's 4 potential total outcomes. The first 3 we talked about, plus somebody that disliked both products. So the probability of that would be 3/4. So this classical definition works great. Why would we have 2? Well, there's some limitations to this classical probability. And the biggest limitation is oftentimes we don't know all the possible outcomes. So let's talk about that for a minute in the next example on relative probability. It's called the relative frequency. It's the proportion of time we see an event occur. We might not know all the events. For example, computer repair times. Right? We took a sample of all the computer repair times in days how long it took us. Now, we took this data and we made a relative frequency distribution table, which, just as a reminder, we did the relative frequency here and the cumulative frequency here, and then just put a cumulative percentage here. Right, and you can go through, you've got the Excel spreadsheet, you can go through every single cell to see all the calculations. And then we just did a histogram over here by doing our bins and then plotting those different bins. Now, what this allows us to do in this table, it says the probability that it'll take 4 days or less are basically 0. Probability that it'll take 8 days or less, we look at the is about 7.47%. The probability that it'll exactly be done on the 10th day is very small, like 0.079, but the probability that it'll be done in 10 days or less is the cumulative probability. So 21% of the time it's done in 10 days or less. So we took our data, made our relative frequency distribution table, and you can see all the formulas are right here, right? We simply did a COUNTIF, and we did our range. If you remember the COUNTIF function, we did a COUNTIF, and we set this range, and we said COUNTIF it's this number of days. We filled that down. That told us how many in the sample were either 0, 1, 2, or 3, 4 days, all the way down to whatever our maximum was, 40. Then we did our relative frequency is just our frequency divided by the total. And then the cumulative frequency is just a summation of everything that comes before. So it's the prior cumulative frequency plus the current period. And then we just did a cumulative percentage by taking that cumulative frequency, again, divided by the total. This allows us to basically come up with a probability based on the proportion of time that these computer repairs. So we can now say, the probability of being 8 days or less or 7%. This is very handy for industries and business because now they know what kind of commitments can they get. Down here, roughly 95% of the time it's done in 25 days or less. Now, there's our histogram, and there's some there's some limitations to this too. Some of the limitations of a relative frequency distribution is what if we improve? What if things change? What if the week we were doing it and these repair times were before we added 2 more staff? So oftentimes you're updating the relative probabilities, and they can change, as opposed to the classical definition. The probability of rolling a 5 on a dice is never going to change from 1/6 because we know all the outcomes and all the possibilities. On a relative probability, they're subject to changing.